In this video, we're going to talk about ionic bonds and exactly what are ionic bonds. So ionic bonds is basically a type of compound. So remember, compounds are basically substances are made up of two or more different types of elements, atoms that are bonded together. All right. Well, an ionic compound is a type of compound in which you have a metal. So these guys, all right, which bond chemically with a nonmetal. These guys, all right. And so let's put into some examples of this. So like for example, let's say we have sodium, right? Sodium is your metal, okay? And then we're going to look at chlorine. Chlorine here is our nonmetal. And so when these two elements combine, all right, or when these two atoms, let me say that, when these two atoms combine, they create what we call an ionic compound. Okay, so what takes place? Like, how do they bond? Okay, how do these two bond together? Well, ionic bonds are formed by the ions. That's why it's called ionic bonds. And so, like for example, if we look at the Lewis dot structure of sodium, we find that sodium only has one valence electron, right? And so sodium, which looks like this, okay, with its one dot. And then we have chlorine. When we look at its valence electrons, it has 7 dots, okay? So it looks like this. Well, what happens due to electronegativity and stuff like that is that the sodium will transfer its electron to chlorine. So you remember, when sodium wants to become an ion, it's going to lose its electron, right? Chlorine, when it wants to become an ion, it's going to gain an electron. So sodium is going to lose its electron or give its electron to chlorine. When this takes place, what happens is now you have a sodium that has a positive 1 charge, and then now you have chlorine, which has a negative 1 charge. All right. And so now, due to the fact they have opposite charges, they will attract one another. So there is an attraction here. The attraction that we have between the sodium ion and the chloride ion, between this positive ion and this negative ion, this attraction is what we call an ionic bond. Okay, and then this is an attraction between opposite charges. All right, and so when we have this, we get a product that's nothing like the original elements that it starts off on. Like when you think about this, all right, some of the physical properties of sodium metal, right? It's silver, it's a metal. It has a relatively high melting point, right? And then when you have chlorine, right? The chlorine gas, it's a gas at room temperature. Another thing, it's poisonous. It's yellow and stuff like that. And so now when we put NaCl together, what we have is an ionic compound called sodium chloride, or AKA table salt, right? So now it becomes this white, what we call a white crystalline substance, or white crystal substance. All right. It's a white crystal substance. It's not poisonous at all. If anything else, I mean, we put in our foods all the time, right? It makes foods taste great. And so it has a completely different physical property. So oftentimes when we have ionic compounds, the properties of those compounds is completely different from the elements that make it up. Okay. Now I want to kind of talk more about this whole idea of a crystal. So ionic compounds typically form crystals, all right? And so what do we mean by crystals? Well, crystals is basically an ionic compound where the elements or the atoms that make them up always come in some type of repeating formation or repeating structure. And so, like for example, if we're going to talk about here's the case. Here's our sodium, and here's our chloride, right, what's going to happen is that usually the compound sodium chloride is not just these two elements bonded together. It's a crystal. That means you'll see repeating segments of sodium and chloride bonded together in a very specific formation. All right. And so what you'll see is going to be something that looks like you have sodium, chlorine, and they're all bonded together in a structure like this, which is, as I said, repeated, where you have the anions always touching the cations in this formation here. So let me just add my chlorines and my sodiums, and then I'm add more of my chlorines. So this is a crystal, all right, and where you have repeating segments of your atoms that are bonded together. And now when we're looking at the ratio, we could see that it's a 1-to-1. For every one sodium, there's one chlorine. And so this is the reason why we simply write it as NaCl, showing that for every one sodium, there is one chlorine. All right, so this is the big thing about ionic bonds.